So for 15 we are multiplying here, but remember we just multiply straight across, and then we can cancel anything from top to bottom, so we can kind of just treat it like it's just one fraction here. But we do need to factor all four of these, the numerators and the denominators. I'm going to factor this denominator first. It's going to be fairly simple, x plus 4, x minus 1. That's this denominator. And then I'm going to factor this denominator here, but that's going to require two steps. I can pull the 2 out first. There's a GCF, which will make it a little bit easier. And then I'm going to come down here and factor this. So I'm going to have 2x and x. And I need to do... oh, no, as it turns out, that's not going to factor anymore. There's no way to get, because I have to do 2 and 1, and so if I put a 2 here, I'll have 2 and 2, which is 4, and if I put a 2 here, I'll have 4 and 1, which is 5. So this is just going to be a quadratic that does not factor down here. So the only thing I can factor out of this is that GCF, so I'm done with that. This set right here, you can look at it, and if you're pretty good, you can see that it's actually going to factor by grouping. So I'm going to pull out a 2x squared, and I'm left with x minus 3 when I group these two, and then I'm going to group these two, pull out a negative 3, and I'm left with, a negative 4, and I'm left with x minus 3 as well. Alright, make sure that you have a negative there and a negative there, gives you a positive. So now I'm going to pull out a big GCF of x minus 3, and I'm left with 2x squared minus 4. And now I can factor a GCF of a 2 out of this. So I have x minus 3, 2, x squared minus 2. So this is how I'm going to factor the numerator. I'm going to put this right here for the numerator. I'm just going to put that 2 in front. So 2x minus 3, x squared minus 2. Now this does not group, so I'm going to have to do p's and q's right here. So I'm going to slide my paper over, and I'm going to do p's and q's up here. So my p value is 8, so I have factors of 1, 2, 4, and 8. My q value is 1, so my p over q's are these right here. So I'm going to set up my synthetic division, 1, 7, 14, 8. And as I'm setting it up, I can see that everything here is positive. I have no sign changes, so I know that I'm not going to have any positive solutions. I'm only going to try negative solutions for this problem. And I think I'm going to try probably negative 2. So 5, negative 10, 4, 8. Perfect. So negative 2 works. And now I have x squared plus 5x plus 4, and I can also factor that. And if I bring this negative 2 down as a factor, that was actually the factor x plus 2. So these three things are from this numerator right here, so I'm going to put them right here. X plus 2, x plus 4, x plus 1. And so now I want to cancel anything that's the same from top to bottom. So these 2's can cancel, and the x plus 4's can cancel. And that's it. Nothing else cancels here. And so my final answer is just going to have a bunch of factors in it. So that's my final answer, and I need to do my domain restrictions. I didn't flip any denominators or anything, so it's just what can make each denominator equal 0. And so we have x cannot be equal to negative 4 from right here, positive 1 from right here, and then whatever makes this equal 0. Well, we don't really know since that's a quadratic. So if I want to see what makes this equal to 0, I have to do the quadratic formula. So negative b plus or minus Now, I don't actually have to do it for very long, because I can see pretty early this is going to be negative 4 times 2 is 8, times 2 is negative 16. I can see right now that this is going to be imaginary, so there are no real numbers that I need to exclude from the domain, because there are no real numbers that are going to make this quadratic equal 0. So these are my domain restrictions, and then these are all my factors that didn't cancel.